A very special good afternoon to you all. This is your tutor of mathematics, Mr. Makari. The contact details are included on the screen, and today's focus is on the exam-based contact classes. Classes that should prepare us for the August examinations that we should be writing in the near future. The contact number in terms of the cell phone is displayed on your screen, which is 081-270-2525. And indeed, my email address is also indicated as emakari8@gmail.com. Towards the end of the presentation, you will be able to see the contact numbers in order for you to contact me should the need arise, and be encouraged to please contact me, because that should help you to prepare thoroughly for your upcoming examinations. The examination format for mathematics, you will be writing two papers. It is paper 1 as well as paper 2. In terms of duration, there is a difference in that paper 1 is 1 hour, is written for 1 hour 15 minutes, 1 hour 30 minutes, whereas paper 2 is 2 hours and 30 minutes. In terms of format, the difference between the two papers, in paper 1 you find, or you will be expected to answer short type of questions, whereas in paper 2 you are dealing with structured questions. The total marks per paper are also differing, in that paper 1 you write a paper consisting of 80 marks, whereas paper 2 it's worth 120 marks. The weight, it is a 40-60 ratio that is used to weigh the two papers. Both examinations are not open book examinations, and therefore they need for you to prepare thoroughly, because you will not be able to use your books or any resources in answering your questions, except for maybe a calculator or so. Again, the second slide, it's again highlighting the fact that we have two papers, of which paper 1 is 80 marks and the second paper is 120. A final pass mark of 50% in combined is required from your continuous assessment as well as your exam. You need to get 50% in order for you to pass. So the two papers put together, you should score 50%, meaning you are writing a 200 mark examination in terms of the two papers combined. For you to pass this course, you must score at least 100 marks in both papers. As an example, you could score 30 or 40 marks in paper 1 and 60 marks in paper 2. The two combined should at least give you 100 marks in order for you to pass, meaning obtaining the sub minimum of the 50 in the examination. Now, the focus of your examination is aligned to the topics that are covered in your exit learning outcomes, meaning the objectives that we have to cover are the ones that are covered within our course. So there is no topic that is more important than others. It says that the question paper is set across all the learning objectives that we have to cover. For example, we have the topic on numbers. We need to know the different types of numbers. We need to know the classification of numbers. We should be able to identify the factors of numbers correctly and use or answer questions that are dealing with numbers correctly. And under numbers, this is where issues of ratio and proportion come into the picture. This is where issues or calculations based on percentages are coming into the picture. So we need to revise the topic on numbers thoroughly, because numbers, that's the foundation, or that's the basis of mathematics that we want to specialize in order to teach to our learners competently. The second set of topics, it's topics that have to do with algebraic representation and formulae. Now in algebra, algebra in general is the study of numbers, where numbers are being studied in general, and that would then give us a representation of numbers in the form of letters. So we need to know the basics of algebra. For example, what are like terms and what are unlike terms? Like terms are the terms that have the same variable raised to the same power. Like terms are the terms that we can add or subtract from one another. When we have unlike terms, we do not add or subtract them. Just as an example, we can look at terms like, if I have 3x compared to 4y, those are unlike terms because the variables, the letters, are not of the same type, so they cannot be added. So they are unlike terms. So we cannot add or subtract unlike terms. But if I have a case where I have, let's say, 3x as well as 6x, these ones here are like terms because the variables are the same letters, meaning both of them are x's. But let's look at, if I have 4x compared to 4x squared, or 4x to the power of 2. Here again, in this scenario, we do not have like terms. Yes, the variables are the same, but the powers, the exponents to which they are raised, is different. The one is to the power of 2, whereas this one is to the power of 1. So these ones here are unlike terms, and we cannot add or subtract them. So that's the basis of algebra, to say we need to know what are like terms and what are unlike terms. Unlike terms. So we need to start with that, and we need to know that. And we need to know how to add, multiply, subtract, and divide algebraic expressions correctly, and indeed to simplify expressions, and indeed to factorize expressions. So all related activities that are covered within algebra, let us do it, and let us make sure we understand it comprehensively. Our book is having sufficient examples and exercises to guide us in knowing what we have to know in order for us to be able to do well on the topic of algebra. Then we have solving equations and inequalities. In this case, it's also important for us to be able to solve equations correctly. An equation, and the difference between an equation and an expression is in that if you look at an expression, you have instances such as 2x plus 5. That's an expression, it's a statement. Whereas if you have an equation on the other hand, you will have 2x plus 5 being equal to 10 or so. So the equal to sign, it's what makes the difference between an equation and an expression. And an expression can only be simplified. We can only simplify an expression, whereas with equations we can solve them, meaning finding the value of x that will make the equation to be equal to 10. So, and in this case, we know that x should be 2.5 in order to make this equation 10 as a case in point. Okay. Moving on, we have to deal with polynomials. Polynomials, the topic on polynomials is basically just an extension or an expansion of the topic on algebraic representations, in that we should be able to divide, multiply polynomials correctly. And especially with the division of polynomials, we need to recall, or we need to relate it to the method of long division that was done, or that was introduced to us in primary schools. We need to revise the long division with numbers for us to be able to perform polynomial division accurately or correctly also. The next topic that is also covered in our exams, it's the topic, or it's the unit on logarithms. And in terms of logarithms, we need to relate logarithms as well as the laws of logarithms to the chapter or to the topic on indices that is covered in algebraic representations as well as under numbers. So logarithms, it's a special set of indices, and the two laws of logarithms as well as the laws of indices, they go hand in hand, they are related to one another. So let us also prioritize the revision of the topic on logarithms for us to be ready to tackle the examinations competently. Of course, the sixth learning outcome that we need to tackle is the learning outcome that deals with sequences and series. A sequence, it's an ordered list of numbers. These numbers follow a certain pattern. For example, one of the most basic sequences could be 1, 2, 3, 4, 5, and continuing. That's a sequence, and it is the sequence of natural numbers where we add 1 to the previous term in order to generate the next term. So we need to be able to know or to identify the patterns within sequences, and we should also be able to tell between a geometric and an arithmetic sequence, the difference between the two, and the generalized formulas that we can use in order to generate the formula for the nth term of the particular sequence that is in front of us. So that is the unit 6. Number 7, it's about drawing and interpreting graphs. So we have different kinds or different types of graphs. For example, the travel graphs, conversion graphs, and so on. We should be able, given enough information, we should be able to draw a table of values and plot the points on the grid in terms of the graph paper, and then draw the relevant graphs that we are required to draw. Now, most important in drawing graphs, the most basic concept that we need to be familiar with, or that we need to be clear on, is the concept of the variables. We have two kinds of variables when we deal with graphs: the independent variable as well as the dependent variable. The independent variable is the variable that is always plotted on the x-axis, and the dependent variable is plotted on the vertical or on the y-axis. So we should always keep that in mind when we are expected to draw graphs. And let us also remember the fact that all our graphs are to be drawn using a pencil, and we follow instructions in terms of the scale that is given when it comes to graphs. A continuation of the scope, we also have to look at functions and their notations. When we talk about functions, we are talking about the composite functions and as well as finding the inverse of functions. For example, if we are told, if as a case in point, we are told that f of x is equals to 3x plus 1, we should be able to perform solutions such as finding f of 3. If we are told find the value of f of 3, it means where we see x, we now substitute with 3. That will then mean 3 times 3 plus 1. And in this case, that will be equal to 10, because 3 times 3 is 9 plus 1 equal 10. So those are the basic forms of functions that we sometimes are expected to deal with, or finding the inverse of that particular function that is given. Or alternatively, we might also be told find f of x equals 15. Now in this case, x is at its place, so meaning f of x should be equated to 15. In this case, then it would mean 3x plus 1 should be equated to 15. And that being the case, it will mean that 3x will be equals to 14, because when we take the 1 across, it will be subtracted, and therefore x on its own will be equals to 14 over 3. So, and that would be our answer. So now, what the implication is here is that we need to know when to substitute the given value into the original function, or when to equate the given function to the given number. So those are amongst the things that we are to cover when we deal with functions. Of course, the next learning objective deals with linear programming. Linear programming, it's about identifying the area defined by certain or by given conditions that usually comes in the form of inequalities. We identify the areas, we draw the lines, and we shade or identify the expected area that should be written or identified with an R or a T or so, as per the instructions. Then we have coordinate geometry. In geometry, we are expected to do calculations relating to the distance between 2 points, the slope of a line, or coming up with the equation of a line given sufficient information. So it is also a critical topic that we need to revise. Of course, statistics, the mean, the mode, the median, we should be able to calculate it given enough information, being it raw data or alternatively being it information that is given in graph form or grouped data, in other words. So we should also be able to answer questions on statistics. Of course, then we have the issue of probability as a topic that we need to deal with. And the probability, by definition, is the likelihood that an event would occur. So, and the probability of an event occurring is usually ranging from 0 to 1. If the probability is 0, then it means that there is no chance that that particular event would occur or activity would occur. Whereas the probability of 1 is 100% certainty that that particular event or outcome will be produced. Of course, then we have the transformations. In terms of transformations, we have to also be able to describe transformations correctly in full, or alternatively, we should be able to identify a transformation that is performed on a grid. We should be able to see that this is this type of transformation, and therefore this is how we describe it. As a case in point, we can look at the three transformations. We have a translation, rotation, as well as a reflection. These first three, the size of the original figure remains the same in comparison with the transformation. Whereas when we look at an enlargement, the figure is different in terms of the size. When we enlarge, we are making the figure bigger. And usually with an enlargement, it carries 3 marks. The marks are coming from stating the name that this transformation is an enlargement. The second mark comes from stating what the scale factor is equal to, the number of times that the figure is enlarged. And the third mark comes from stating the center from where the enlargement is performed. So this would always carry 3 marks in terms of the transformations. A translation usually carries 2 marks. And that is so because in terms of translations, we only give the translation vector as well as stating the fact that it is a translation. A rotation carries between 2 to 3 marks because we have to state that it is a rotation. Then we state the center of the rotation, and then we also state the angle and the direction of rotation, 90 degrees clockwise or anti-clockwise. And so that will then lead to the 3 marks that are usually allocated when it comes to rotations. Reflections are usually carrying 2 marks only. And that is so because with reflections, we only talk about the fact that it is a reflection, and then the equation of the line of reflection, where the line or the mirror line is to be placed in order for the reflection to occur. So that's basically what it is when we talk about transformations. Of course, we also have the unit on vectors that we need to deal with, and that we should also be competent in, because it's part of the learning outcomes that we should cover in our subject. Now, for our particular purpose, there are some few highlights that I wanted you to pay special attention to for this particular exam, because at times students are experiencing difficulties in topics that relates to the calculation of speed, distance, and time, especially where the conversion from one unit into another unit is involved. For example, you might be told, or you might be given a graph that gives you information regarding distance and time, such that, or where distance is given in kilometers and the time is given in hours, kilometers per hour, in other words. But then during the course of the question, you may be required to give your answer in kilometers per minute, meaning you need to know the conversion between hours and minutes, and indeed between minutes and seconds. So we need to be able to do those conversions correctly. And added to that, we should also be able to interpret travel graphs correctly. For example, at times the area under the graph is the distance covered. And when is that situation? Is it when we have a speed time graph, or is it when we have a distance time graph? We should be able to tell, and we should be able to know what that area under the graph gives us in the different scenarios. Of course, we should also be able to calculate the volume of combined shapes, especially the volume of cylinders and the volumes of spheres. We should be able to do that correctly. Of course, I spoke about functions, and indeed we will also have composite functions in our examinations that we need to prepare for. And of course, linear programming, as pointed out, identifying an area defined by given inequalities and shading it accordingly on our graphs. It's a critical skill that we will need to demonstrate, as well as the topic on locus. Now, locus, it's about defining a set of points under a given condition. So we should also be able to draw accurately, because with locus, it's about scale drawing. Our drawings to a given scale and satisfying the conditions within the given instructions. And therefore, at this point in time, let me encourage you to have your mathematical sets at hand when you are dealing with these type of topics. Trigonometry, we need to know the 3 trigonometric ratios and be able to apply them to solve the problems. For example, it is the sine, the cosine, and the tangent rules. We should know when to apply them and how to apply them, and indeed how to use our calculators to calculate the cosine of an angle or the sine of an angle, and so on, in order to eventually get to the correct answer that we are expected to do, or to give rather. Now, most important again, related to trigonometry, is the theorem of Pythagoras that will also come in handy during our examinations. We should know it, and we should know how and when to apply it correctly in order to take advantage of it in solving problems that may require us to utilize the theorem of Pythagoras as a means of getting to our answers. Of course, in general, to sum up, we are expected to answer all our questions in black or blue ink. Black or blue ink only. For diagrams, for graphs, we are expected to use a clear, sharp pencil. No Tipex or correctional fluid is to be used during examinations, and we must have a scientific calculator and indeed a mathematical set with all the geometric instruments in them in order for us to fully and be competently able to answer our examinations to the best of our ability. At this point in time, let me wish you well for the upcoming examinations, and most importantly, let me again leave you with my contact numbers in terms of the cell phone number as well as the email. In order for you to contact me should the need arise, please do so, especially any day after 2 o'clock midday, from 14 hours until 8 o'clock in the evening. I am available to answer to your queries. If the phone is not answered, leave a message. I should be able to get to you whenever I get the chance to do so. But before 1 o'clock or before 2 o'clock, I would usually not be able to respond to you because most of the time I will be busy with other engagements. Thank you. All the best of luck going forward.